Okay, so in 13.2, we are looking at different ways to measure angles. So you all know how to measure an angle with degrees, okay? We're going to learn how to measure with radians just a little bit today. It's similar to when you measure how long something is, and you can either measure it in inches or in centimeters. You're still measuring how long it is, it's just a different unit of measure. So this is the same thing with angles. So we have degrees and we also have radians. We're going to be talking about angles first of all, and they all are going to be on an XY graph in this section. They're all going to have a starting or initial ray on the x-axis, and then the terminal ray is going to be anywhere on there, okay? We always measure counterclockwise unless the angles are negative, then we spin the opposite direction, okay? But we always go up first for the positive ones. So let's estimate these right here. So what would you estimate this first angle to be in degrees? How many degrees would that be? About 80 degrees, I would agree. Okay, so it's really just measuring it against how far away it is from 90, which is straight up. So I would guess that would be pretty close to 80. What about this one? I'd say less than 150. Does it kind of look like it's going right through the middle of that quadrant? Which would mean it goes how far beyond 90? 45 degrees past there, so I would say it's about 135. That's kind of the thought process you want to be going through. What about this one? I'd say it's a little bit past halfway in that corner, wouldn't you?
50.
Negative 60 would be a good guess, or negative 50, somewhere around there. What about down here? Maybe a little bit more than that.
210.
200 or 210, somewhere in there. Okay, it's going to be past 180, which is that line straight to the left. What about this one? We go a full circle, so we've got 360, and then how much more? About 45 more, so 405, somewhere around there. All right, this one. We go one full circle, two full circles, so right here is how much? Okay, and then about how much more did we go? 100, 110 more. Okay, so
835.
sure. Somewhere around there. Okay? Questions on that? Those are just estimates, just to kind of get used to what these angles are doing. Now I want you to draw these four angles. Okay, so I'll give you a couple second head start on me. Put them just your best guess. All right, so I'll put my answers up here. You do have to make sure that you have the curved arrow so I know which direction you were spinning. That's part of the answer. Can someone shut the door, please? Okay, and then this one, the 500, we're going to have to go over a full rotation, right? So we're going to go 360. How much more do we have to go? What's left? 140 degrees. Okay, so that would be somewhere around there. So it's very important to have that arrow so I know exactly how many times you're spinning around to make sure that you got the problem right. And then 260 would be at almost 270, which is straight down. And remember, those positive angles start by going up first. The negative angles go down first as they spin around. Questions on drawing angles? These are going to be possible test questions right here. We can handle this section, drawing the angles. Okay. All right, we're going to talk about coterminal angles. So a coterminal angle simply means that it's an angle that lands in the same spot. Okay, so this 405 degree angle right here, we could also just focus on this angle. How big is that angle? That is a 45 degree angle. So a coterminal angle with 405 is 45. We could also just spin the opposite direction. So this is negative 220. What would this angle be? Uh-huh. Same thing here. What's the positive direction for that one?
260.
Okay, so really, what are you doing every single time to find those numbers?
Subtracting.
You're either subtracting or you're adding 360, right? Because then one full rotation would just have the angle land in the exact same spot. That's a coterminal angle. So you're taking your angle and you're adding or subtracting 360 degrees every time. That's simply all you have to do. So there's going to be a section of the homework where you're going to be doing that. Just adding and subtracting 360. All right, so let's start talking about what radians are. So right here is the formula, per se, I guess, of how they're figuring out what the radians are of an angle. So what they do, these are radians here. To get the radians of this angle right here, they take the length of this arc, however long it is. Okay, let's say it's like 5.2, and then they would divide it by the radius length. Maybe that's 2.1. Dividing those two numbers gives you the radians of that angle. So the most common ones that we're going to see are right here. So radians can be written in terms of pi. Okay, these are the ones that you're going to see most often when you take trigonometry for a full semester next year. Those of you that signed up for that, you're going to be kind of living on this unit circle right here. So 0 is obviously the same thing as 0 degrees. What is this one in degrees? That's the same thing as 45 degrees. This one is 180, and this one 270. What's this one? That's a full rotation. 360 and 2 pi are the same thing. What would you guess these are? This one's 30, and this one's, nope, another guess? 60. Okay, so those right there are the most common. Those are the ones that you're going to want to kind of get used to seeing, especially knowing that 2 pi is 360 and pi is 180. These four on the points are definitely ones you're going to want to memorize. These ones are pretty easy because pi over 4, the 4s go with the 4 and the 45, and then these just go with the opposite number. 3, pi over 3 goes with 60, pi over 6 goes with 30. Okay, so those are the most common ones, but we can change between the two, and I'll show you how to do that quite easily. All right, so we just talked about this. If we are in radians, what are we going to be adding and subtracting instead of 360? If we're working in radians. Yes, 2 pi. Okay, and if you're working in decimal form, what is the decimal of 2 times pi? 6.28. Okay, so you're either adding 2 pi, subtracting 2 pi, or adding 6.8, subtracting 6.8. Okay, so we are looking here. Now, if we're adding and subtracting 2 pi, so let's say we have plus 2 pi, what do we need to make sure we do when we add and subtract fractions? We need a common denominator. So we want to change this 2 pi. So if we have 2 pi over 1, but we need a common denominator with 5, we just multiply by 5, right? So really, what do we have here? We have 10 pi over 5. Okay, just getting that common denominator. So that is that number right there. And then we also have to take 3 pi over 5 minus this number. And remember, this 10 pi over 5 is really just 2 pi. We just have a common denominator with them. All right, so what is our positive coterminal angle in radians? 13 pi over 5. The negative coterminal angle? So here are our coterminal angles. Remember, these are angle measures, but they're in radians, not degrees. Okay? All right, this one. we would need a common denominator, so we have 2 pi over 1, but we need a common denominator with 4. So we just multiply by 4. So we are adding what number? This fraction is what? 8 pi over 4. And then we have pi over 4 minus our 2 pi, which we changed to have a common denominator. What do we have for our numbers? 9 pi over 4 and negative 7 pi over 4. So we have one coterminal angle that's positive and one that is negative. Now, if they give you the radian measure in decimal form, so it's not in pi form, all we do is we add and subtract 6.28, and that's it. So help me out with these numbers here. Mm-hmm. Okay, good with that? So if you're in degrees, you add and subtract 360. If you're in radians, you add and subtract 2 pi to find those coterminal angles. The last thing we want to talk about is how to switch in between the two forms. So if you have degrees, how do you switch to radians? And if you're radians, how do you switch to degrees? Okay, and the way that you switch in between them is very similar. So we're going to talk about how you know which one to use. Everyone good on this slide? Okay, so if we're changing from degrees to radians, we're going to multiply by pi over 180. Okay, so let's say we have this degrees right here. We have 48 degrees. All we have to do is multiply by pi over 180. And we have our answer. Now we're going to keep it in terms of pi, which simply means pi is going to be in the answer. So we have 48 pi over 180. Now technically that is the answer, but I want you to simplify it. So what you do is take your calculator, put 48, ABC button, 180, don't punch in the pi, just the two numbers. 48 over 180 equals, and it simplifies it for you. What is that? How much? 4/15. Okay, so it's really 4 pi over 15. That right there is your radian answer in terms of pi. Now, if we want decimal form, all you do is put that in your calculator, the whole thing, 4 times pi divided by 15, and we get what decimal? How much? Okay, so that's the process there. Now, if we're going backwards, changing radians to degrees, all you do is you flip your multiplier. Okay, now here's how you can remember which direction to go. If we have radians, we're going to have pi in there, right? And we want to cancel out pi, so where would we put the pi, the top or the bottom? We want to put pi on the bottom so they cancel out, so that it's not in radians anymore. So if we multiply by 180 over pi, pi's cancel out, and all you have to do is take 3 times 180 and divide by 7. What do we get? Okay. Now the same thing is true if you have a decimal radian measure. So let's say we had 2.58 in radians. We still multiply by 180 over pi. And all you do is put this into your calculator. So you take 2.58 times 180 divided by pi. What do we get for that one? How many degrees is that? In the hundreds? Okay. So that would mean if you had 147 degrees right here, that radian measure would be 2.58 radians. Any questions?